Okay, so here we go. 1113 was a little bit of a rest. Now you're going to pay for it. Here are three equations, formulas, that we're going to use to convert between polar and rectangular forms. Sometimes you're going to go from polar to rectangular. Sometimes you're going to go from rectangular to polar. Now let's actually take a look. It says convert the polar equation. Now I want to highlight something. They're already feeding you information. Notice this is R equals, R equals, R equals. So, a little exception to the rule here. There is no R equals. It's a little unique problem over here. But what I want to say to you is, when this says convert the rectangular equation to polar form, we need to know that you're not done until you have R equals stuff. Now I know that's very ambiguous, but it will make sense as I continue teaching. Now, what I'm going to do is take this pink marker and tell you that this is polar, polar, polar. And rectangular, because remember, if we plot a point, this is a rectangular coordinate with x's and y's. So if I plotted a point like 2, 3, here's my x, here's my y, 2, then 3. My point is, x's and y's are what defines rectangular forms. So rectangular form could be this, this, or this. So, with that being said, it's saying convert from polar equations to rectangular form. In other words, when you're done, you will only have x's and y's using substitution. So, I think the best problem to start with, to be honest with you, is right here, example 3. So if I look at this and I think, okay, substitution, substitution, how can I take something from here and substitute it in for here? Well, you can't. So that means you need some work. So I want you to notice this, x equals r cosine. Now notice, we have cosine, but it sure would be nice if we had an r sitting in front of it. Now, ignore the -4, don't let that distract you. So it's like, well, how could I mathematically get one there? Well, I could multiply this side by r. But if I multiply that side by r, I have to multiply that side by r. And I think you might be able to see where this is going. What's r times r? R squared. What's r times this? Now I could write like -4 cosine theta r, but I want you to know that we're looking for, trying to create r cosine theta. So I'm going to write it as -4 r cosine theta. Now I want you to look. Here's a polar expression. Here's a polar expression. The -4 just kind of comes along for the ride. What does r squared equal? That equals x squared plus y squared. See, we're introducing our x's and our y's, but we had to be a little creative to do it. And then what is this pink stuff? Well, that pink stuff equals x. And we're done. Now, that's all they're asking us to do right now. Now let's go to this one. Now I want you to notice something. We have cosine and sine. We need these in order to substitute. So we're like, well, what do I do with cosecant? This is why I did this one second. Well, I don't want that there, so I'm going to divide by cosecant. Just get rid of it. And if you have that thought, it'll just guide you into the promised land. Whoops, cosecant theta. Now, we have to think for a second. What is cosecant the reciprocal of? Cosecant is the reciprocal of sine. So I have a 1 here. I have 1 over cosecant, which is the same thing as sine. So here's an r, and I'm going to put that in front because I can see what's coming. I'm going to go r sine theta equals -2. So just by thinking this thought, I don't want cosecant, because there's nothing in my chart that says cosecant. Let's divide by it to get rid of it. Things kind of fall into our lap, but you got to look for 1 over cosecant. 1 over cosecant is saying, what's the reciprocal of cosecant? Sine. And now I think, okay, I'm not done until I have only x's and y's. Well, what's r sine? R sine is equal to y. So y equals -2, and I'm done. Let's go to this one. Same sort of thing as this. We don't have a secant in our little box here, so we got to get rid of that thing. And then we got to do the same thing over here. These cancel, so I end up with r equals, now this one's a little different, but this, ignore the 3 for a second. What is the reciprocal of secant? In other words, 1 over secant equals what? Well, that would be cosine. That's just a different way of saying secant is the reciprocal of cosine. So I'm going to substitute this. I'm going to put a 1 times 3 over secant. I'm going to really concentrate on 1 over secant, and I'm going to replace it with cosine. So the 3 is going to go in front, 3 cosine theta. Now, we made a good step. We got rid of secant. But now we don't have anything to substitute. We need an r squared, and we need an r right here. Well, make it happen. Multiply by r. So I get r squared equals 3r cosine theta. What does r squared equal? X squared plus y squared. What does r cosine equal? It's right here. It equals x. And you are done. All right, let's keep going. This one's kind of wacky. Well, it would be nice if there was an r in there. It would be nice if there was an r right there, and it would be really nice if we had r squared instead of r. Well, hopefully you're seeing the rhythm here. Let's multiply everything by r and make it look right. So r times r is r squared. That's easy. Where should this r go? Right in between. So 4r cosine theta minus 4r sine theta. Now, what's r squared? R squared is x squared plus y squared. What's r cosine? Well, that's x. What's r sine? Well, that's y. You've eliminated the r's and all the trigonometry jargon, and you've replaced it with x's and y's. So you're done. You've converted it to rectangular form. All right. So let's go to this one. Convert the rectangular equation. Remember, these have x's and y's to polar form, which means we're not done until we got r equals stuff. Well, we take that x and we don't want it. What does it equal? Well, it equals cosine theta. So we're going to replace it with what it equals. And, whoops, I forgot the r. R cosine theta equals 5. Now, we're not done until we solve for r. So we're going to divide by cosine, and if you stopped right there, you're not wrong, but math is challenging you to remember that 1 over cosine is asking you, what is the reciprocal of cosine? Well, that would be secant. So we have 5 secant theta. So my answer would be r is 5 secant theta. And you're done. You converted this rectangular equation into a polar equation. Let's go to here. Well, x. What's x? X is r cosine theta. What's y? R sine theta equals 2. Don't forget, we got to solve for r. Look at this. This has an r, this has an r. Take an r out. 3 cosine theta plus 4 sine theta equals 2. I know this is weird, but if you had 2x equals 8, you wouldn't think dividing both sides by 2 is weird. That's all we're doing. We're getting rid of this by dividing by it. It's just a lot, so it's gone. And then it's all, we got to do the same thing to this side. So I get r is 2 over 3 cosine theta plus 4 sine theta. Now I know you guys have been hit with a bunch of problems where these problems just don't seem to end. It's like, well, this must simplify into something. Nope, not in this case. Well, how are you supposed to know? Practice, experience, this is just a mess. There's nothing you can do with this. So let me pause this for just a moment. All right, so these are going to get a little bit more challenging. So we take a look at this. We're like, hey, there's something we can do here. So that's the same thing as y minus 1 times y minus 1. Remember, we're trying to get rid of x's and y's. So we get y squared outside inside minus 2y plus 1 plus x squared equals 1. Now I want you to notice something. X squared plus y squared equals r squared. So these two things come out. It's r squared. Now what's y? Y is equal to r sine. So it's minus 2r sine theta. And if I subtract 1, these just cancel. So this equals 0. Now don't forget, we're not done until we have r equals some stuff. Something interesting happens. Don't forget what r is. R represents a radius. I'm going to come back to that in a minute. But I look at this and I'm like, well, I don't know how to solve for r. Yes, you do. Factor out an r, and I have r minus 2 sine theta equals 0. Now we have two scenarios. R equals 0, or this stuff, r minus 2 sine theta equals 0. Now we're gonna use a little common sense here. R equals 0. Well, that's saying the radius is 0. That means it's nothing. Very rarely in math does something like that happen, but right there it does, just using a little common sense, knowing what r represents. But here, I just add 2 sine theta, add 2 sine theta, and I get r is 2 sine theta. So that thing equals this thing, as weird as that seems. Last one of those types forces you to square this. So it's x minus 1, and square that. Y plus 4, y plus 4. Now these are handmade to work out, so watch what happens. That is not a random 17. So if I multiply this out, I get an x squared outside inside minus 2x plus 1. Same thing here, plus y squared outside inside. That's 8y plus 16 equals 17. Now, a couple things I want to jump out at you. X squared plus y squared. What does it equal? R squared. So these come out. Always be looking for those. R squared minus 2. How do I take that x out? By putting r cosine theta in for that. So that's gone. I want you to notice 1 plus 16 is 17. So these cancel with that. And then I get plus 8. What's y? Y is r sine theta. And that equals 0. Now don't forget, we're trying to solve for r. What a crazy thing this is. Some of you might think, well, that's a trinomial. No way, Jose. Factor an r out, we'd be left with r minus 2 cosine theta plus 8 sine theta equals 0. Now when that r comes out, just like this r came out, and you're like, oh, that's r equals 0, that doesn't help us at all. This does. So I'm going to add 2 cosine theta, subtract 8 sine theta, and I'm going to do the same thing over here. Whoops, this is supposed to be cosine. Minus 8 sine theta. Getting a little messy here. And r equals this. 2 cosine theta minus 8 sine theta. And again, as wacky as it seems, this is the exact drawing or graph as this. All right, last two things. Convert the rectangular coordinates to polar coordinates. Sketch to make sure it's in the correct quadrant. So if we look at this and we think, okay, negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. I'm going to plot that point, and I'm going to go ahead and make it a spinner, because that's our r. This is negative 4. This is negative 7. How do we find our r? Well, good old Pythagorean theorem. A squared plus b squared equals c squared. 16 plus 49 equals r squared. 65 equals r squared. Take the square root, and there it is. R equals the square root of 65. So we know our polar coordinate is going to be, remember, it's r theta. So we found our r, square root of 65. Now this hint, sketch to make sure it's in the correct quadrant. Why? Watch, you guys. So I'm going to find that using tangent, because I got opposite and I got the adjacent. So I'm going to go tangent of theta equals opposite over adjacent, which is just tangent of theta equals, I'm going to convert that to a decimal, 1 3/4, 1.75. But now I got to go second tangent with my calculator. So let's do this. We haven't done this in a while. So second tangent 1.75, and my calculator tells me 60.25. We'll call it 60.3. So this is 60.3 degrees. Now if I leave that as my answer, it's wrong, because that is this. This theta is how far you spun your spinner to get there. So remember, we got to go 180 plus 60.3, so that'd be 240.3 degrees. And there's my polar coordinate. All right, last problem. Got that rectangular coordinate, 5, 0. So 1, 2, 3, 4, 5. There it is. So here we go. All right. Well, I just realized something. On this problem, I realized I wasn't quite done with this one, but we'll fix it. So that's 5, 0. Well, how do I get there using spinners? Well, I just failed to remember that when you're going from rectangular coordinates to polar coordinates, there's always two polar coordinate answers. So this one will make sense, and then we'll carry that over to here. So how do we get here in polar coordinates using r theta? Well, you can see our r is 5. That's the length. How far did we spin our spinner? We didn't. It's just right there. But if we did spin it over here, and there it is, that's length 5, we would also have this polar coordinate, -5, 180 or pi. I'll just put 180. Because if we spun that spinner all the way here, 180 degrees, but then that negative means polar opposite, we'd end up at that same spot, 5, 0. So how do we apply that idea to this problem? Well, get out a fun little colored marker and just draw it right here. And we got to do some math here. Now we found out that that was 60.3. So I crossed it out, said it was useless. Well, it's really not. 60.3, if we spin it there, but the length of our spinner is still 65, so this is still the square root of 65. I could go like this. I don't know why I made it so big. Negative square root of 65, comma, and then 60.3. So there's really two answers, because if I spun it there, it'd go up, and then 60.3 degrees, it's the square root of 65, but that negative says from here, go totally opposite, and it would end up in that same spot, -4, 7. Tricky little problem. All right, so good luck on your homework, you guys.